In today's session, we are going to dive deep into a critical architectural component of your APIs, global exception handling, middleware, and custom error responses. Before we jump into the code, let's look at today's agenda. We will start by briefly reviewing what is web APIs. Then we will define what is a global exception filter is. More importantly, why we should use it in modern enterprise applications. Finally, we will understand about problem details and walk through a complete hands-on demo. By the way, welcome to .NET Mirror channel. If you are joining us for the first time and want to master the Microsoft technology stack, make sure to subscribe to the channel and hit the bell icon so you never miss an update. Let's set the baseline. What exactly is ASP.NET Core Web API? ASP.NET Core Web API is a cross-platform open source framework designed specially for building HTTP-based services. In simpler terms, it is the bridge that allows different applications like mobile apps, web frontends, and IoT devices to communicate with a central server. Because of its lightweight architecture and high performance, it is the ideal framework for creating RESTful applications on the .NET platform. So, what is global exception filter? A global exception filter catches unhandled exceptions that occur during control action execution, allows you to return a standardized error response. Depending on the version of framework, developers use different approaches. In the legacy Web API 2 and MVC, we relied on exception filter which intercepted unhandled errors specially thrown from within the execution of context of a controller. Later in the .NET Core and .NET 6, the standard shifted to custom middleware which captures exceptions in the HTTP pipeline stream before they escape the application. Today we are using IExceptionHandler in .NET 8 and above. This is the modern standard approach using native interfaces for granular control without custom middleware overhead. You might ask, why should we use global exception handling? Implementing global exception handling in an ASP.NET Web API centralizes error management into a single location, removing the need to wrap every individual control action in the repetitive try catch blocks. There are four primary pillars to this. The first one is centralized error logic. It gives you a single point of control to manage all unhandled application crashes from one isolated component. This helps eliminate code duplication. You avoid prepping every endpoint with the identical boilerplate error logic. Ultimately, this improves maintainability, allowing you to update response styles or logging rules universally without editing hundreds of files. Second one, enhanced security. It is vital to prevent data leaks. You must mask technical stack traces, database schemas, and raw line numbers from public view. Global handling allows for environment segregation, where you can show rich diagnostics to developers locally but show generic messages to production clients. This results in massive vulnerability reduction, blocking malicious actors from mapping API weakness through system crash raw text. Third one, consistent client experience. It ensures standardized API schemas, allowing you to return structured error objects such as industry standard RFC 780 problem details, regardless of where the failure is occurred. It provides predictable HTTP mapping to map specific application exceptions cleanly to proper status codes like 404 not found, 400 bad request. This front end friendliness empowers client side single page applications to parse error responses with uniform validation logic. The fourth one is streamlined observability. It guarantees reliable monitoring, ensuring every application crash triggers a diagnostic write log to a Seri log or Azure Application Insights. It also enables the trace correlation, generating unique tracking IDs in the central pipeline so users can reference specific logs when opening a support tickets. Let's look at the implementation of the code. Here is the sample code. First, we define a handler. We create a global exception handler that implements IExceptionHandler. Inside this class, we implement the try-handle async method, which takes the HTTP context, the exception, and a cancellation token. Inside this method, we log the error and write a standardized problem details payload to the HTTP context response. And finally, we return the true, which marks the exception as fully handled. Second, we must register this in our program.cs. We call builder.services.addExceptionHandler. Give your class name to add our custom handler to the dependency injection container. We also call builder.services.addProblemDetails. Finally, we call app.useExceptionHandler, making sure to ensure this middleware configuration sits early in the app pipeline. Now, let's switch over to the Visual Studio for a live demo where we will build this from scratch and test using the scalar to see the exact problem details response in action. In the Visual Studio, I have created a ASP.NET web application called Global Exception Filter Web API. In my previous video I talked about how to enable scalar for CRUD web API. You can go and watch. I'll provide the link in the description. The same code base I have taken over here. I have cloned this repo to my local application now, and if you run this application it has CRUD operations. If you look at the endpoints, we have get all and get by ID and a post as well as patch. Now if you make a get call request and if you send the request, it will try to return all certifications. So now if you see here, it has four certifications. Now let me try to invoke with ID 5. It says certificate with ID 5 is not found. Now if you look at the code, we pass the ID as 5 and we got error as certification with ID 5 is not available. Let's disable not found code, and this time what we will do is we will throw an exception saying key not found. Now we are throwing key not found exception. Now let's send the ID as 5. Let's make a request. Now if you look at the code, we got 500 internal server, which is a text plain format. And if you see here, we got key not found exception. It says the requested certificate is not available. But the problem here is it is showing entire our stack trace, including the file names where the exception is coming. In the production grade application, we should not be doing like this. Now let's understand how to solve this using global exception handler. In a bigger applications, the developers may throw exceptions like this. And if you see here, we are handling properly, but there are scenarios where you may get unhandled exceptions also. Now let's understand how to handle these scenarios with global exception handler. Now let's go and create one folder called infrastructure. Global exception handler. Now let's implement IExceptionHandler. Let's inject the iLogger here. Yeah, now if you look at here, I'm trying to inject logger to this particular class. Now let's try handle async. So we'll say log error. Let's add a message. Let's add mission as well. And also let's add the trace ID. Now if you look at this code, I'm trying to log unhandled exception. I'm putting the message, the mission name, and also the trace ID. If you look at the code, I've added a switch statement which says key not found exception. When key not found exception comes, it takes not found as the status code. This is the title, and we are throwing the complete message which we are throwing. Now any other exceptions, it goes and logs as internal server error. Now the same error we are forming here, and we are sending the status code and the content type as application.json. We are sending custom error response as the response to our API. Because we have handled exception here, we are sending as true. Now we created our own global exception handler. We have to register this in program.cs. In the program.cs, in order to register our global exception handler, we need to add three steps. The first one is add problem details. I will explain about this. And we are trying to put a service called add exception filter, which is our class. And the third step is we have to say use exception handler. Make sure that the third step you're registering before routing and the authorization. Now let's run the app. Now let's send the ID as 5. And if you look at the response now, it's application JSON type. Status code is 404. Title is resource not found. the exception is which we raised from the controller, and this is the trace id. And if you go to the logs, you can see the complete exception. It says unhandled exception, the machine name, as well as you can see the trace id. And if you see here, it is completely logging the exception how you are getting before. Let's understand the code. The log error is logging the complete exception which has the trace id and the complete stack trace. So in the production application, someone can provide you this trace id. You can go to your application insights, query this particular trace id, and you can look at the complete error details to fix the error. But to the end user, we are not showing that complete stack trace. This is because we are enabled global exception handler. The next piece of code is key not found 404. We got this title. The message description is exception.message, which we have raised in the controller, which is this error which is showing over here. If you look at the code what we have written here, we are returning a custom error response where we have our status code, title, details, and the trace id. The biggest drawback of using custom error response is a lack of standardization, which forces client developers to manually map and parse every single APIs. With custom error response, you have to write lot of logic to create custom error objects in both backend controllers, and client SDK creates unnecessary boilerplate. And also it requires lot of custom middleware, filters, and serialization. To overcome these problems, we have a concept called problem details. Let's understand. Problem details is a standardized machine readable format, RFC 7807-9457, used in web APIs to communicate errors consistently. Let's look at its core structure. A standard problem details response contains the following key properties. Type, a URI reference that identifies the specific error type, which often links to documentation. Title, a short human readable summary of the error. Status, the HTTP status code such as 400, 404, or 500 internal server. Detail, a human readable explanation specific to the current error instance. Instance, a URI reference that identifies the specific occurrence of the problem. The primary benefits of using this format includes consistency because every endpoint returns errors in the exact same format, making the front end and API integration easier. It provides standardization because it adheres to IETF standard, meaning client applications can use universal interceptors or middleware to parse API errors. Finally, it offers extensibility. You can easily append custom key value pairs like trace IDs, timestamps, or validation dictionaries to the base object. The entire specification of problem details you can find from this particular website. I'll provide the link in the description where it talks about what is 500 internal server. You can find complete specification from this documentation. Let's go back to the code. Now this time what we will do is we will comment the custom error code. Let's replace this custom error response with problem details. Let's replace with new problem details. Now we are passing the status code, title, the details. Let's pass the type also. Let's add the trace ID as well. Now let's put the same status code. Now here instead of application.json, we'll say application slash problem as a JSON. Now let's replace customer response with problem details. Let's run the application. If you look at the code now, we are getting the problem details parameters now, the type, title, the status and detail, even the instance as well. We are getting the trace ID as well. And if you look at the code, yeah, we have status, the type, the instance, and the details. In this way, you can send the structured format. And let me show you one more example. Let's take the post example. Let's make a request. So in the post example, I'm trying to send the bad data. Now if you look at here, it says 400 bad request. This time the JSON is a application slash problem JSON. Now let's extend one more exception type. So let's take it as unauthorized exception. Now we have added one more exception. So let's go and implement this in the controller. In the controller, we don't have delete endpoint. Let's go and add it. So in the delete certificate, let me stimulate one failure. We'll say throw new unauthorized exception, and let me put a comment. So now in this particular endpoint, we are trying to simulate an exception saying that you don't have permission to delete the certification ID. Let's go and run the app. Yeah, now we got our delete operation. Let's pass a certification ID. So now if you see here, it is sending the problem details, which says access denied, and we got 403 error. It says you don't have a permission. This we got from the controller. In this way, you can go and extend your exceptions in the global exception handler. Now, if you look at these exceptions, these are out of the box from the ASP.NET. Now let's go and implement our own exception. So in this, let me create a class. Let me call it as cert out of slot exception. Let's go and implement exception class. Let's try to implement the base class. Now let's put our custom exception class here. So instead of bad request, let me use as conflict, and this is the title and description. Now let's raise this exception in our controller. In our patch endpoint, let me stimulate some data. So here we will use our own exception class. Now if you look at the code, I'm trying to simulate some number. So now let's go and run this. And this time we have to select the patch. Let's test the request. I'll send some quantity. Let me put a ID. Look at here. Now we are getting our custom exception. It says certification out of slots. We got 409, which is a conflict. And this is the endpoint. We got the error. And we got our own error message here. Like this, you can go and add your own exceptions and raise those exceptions, which will be handled within the global exception handler. With this, we are done with the demo. We looked at what is global exception filter and why you should use global exception filters. And we tried to implement one custom error response. Then I've extended our custom error response with the problem details. And at the end, we have created our own exception class and implemented with the problem details. In this way, in your application, you can handle the exceptions globally with the global exception handler. Thank you for joining. If you find this video helpful, please give it a thumbs up and share with your fellow developers. Please subscribe to our channel. Click on the bell icon to get more .NET and Azure updates. Thank you for watching. See you in the next video.